Good morning, this is Professor Parker, and this is All This Math, and today we're going to solve a quadratic equation by completing the square. Yeah, I decided not to write the word square out. I decided to give you a little pictorial illustration of a square. All right, so completing the square. Completing the square is actually the method by which we can derive the quadratic formula. We're not going to do that today, but I just wanted to throw that out there just to show how completing the square and the quadratic formula are interconnected. Another method that's really popular for solving quadratic equations, and we know this is a quadratic because the biggest exponent is a 2 right here, right, is factoring, right? So if we're not factoring and we're not using the quadratic formula, then we are completing the square. Now, there are a series of steps that we have to follow in order to solve by completing the square. All right, first step, we want to isolate the x terms on the left side of the equal sign. All right, this x squared and this 2x, we want this on the left side, so we want to get rid of this negative 8. All right, so I get rid of the negative 8. I basically add 8 on the left, and I add 8 on the right. These cancel out, and now I just got x squared plus 2x equals 8. Right? All right, that's my first step. Now, my next step is where I actually complete the square. Now, for many years, I taught this method and even learned it when I was younger in high school, and whatnot. And I didn't really know what that meant to complete the square. I knew how to do it, but I didn't understand, like, why is it called completing the square? Well, it's called completing the square because, and it's actually an abbreviation, it's a shortened version of a longer title. You're really completing the perfect trinomial square. So this is a binomial, right? But you're going to make this into a trinomial, right? And it's going to become a perfect trinomial square, which you might be familiar with if you've ever factored perfect trinomial squares. Now, this is the formula that you need to get comfortable with in order to complete the square. B over 2 squared. B over 2 to the second power. Now, the next question you should be asking is, well, where does B come from? I see that's an exponent 2. I see that's the denominator 2. But where does this B come from? B comes from right here. B is positive 2. A is the coefficient of the x squared term. B is the coefficient of the x to the first power term. All right? So that means in this particular problem, our B over 2 squared is going to be 2 divided by 2 squared. Follow the order of operations, right? 2 divided by 2 gives me 1. 1 squared is 1. So now with this 1, this enables me to complete the perfect trinomial square. All right? I'm going to complete the perfect trinomial square with this positive 1. So what does that look like? It looks just like this. It looks like x squared plus 2x plus 1 equals 8. But again, it's an equation. We got to stay balanced. In an equation, we got to stay balanced. Just like in life, we should be balanced. If I add 1 on the left, I got to also add 1 on the right side of the equation. So boom, that's that. I added 1, I added 1. Where'd this 1 come from? B over 2 squared. Whenever you're doing any type of math problems, you should constantly be asking yourself and constantly be thinking about, where'd this number come from? Where'd that number come from? Where'd that number go? What happened to that? What happened to that? All right? Like, where did this 1 come from? B over 2 squared. Why do you have it there? Because we're completing the square. I created a complete perfect trinomial square. This right here is an incomplete perfect trinomial square because it's only got 2 terms. So it's not a trinomial yet. I got to make it into a trinomial and make it into a complete trinomial. Now it's a trinomial. It was a binomial. Now it's a trinomial. 1, 2, 3. It used to be 1, 2. It was incomplete, complete, incomplete, complete. All right. So now you're understanding why it's called completing the square. All right. So now we're going to simplify a little bit. On the right side, I'm going to simplify. I'm going to make this a 9 because 8 plus 1 is 9. Now, I made it into a perfect trinomial square so that I could factor it in the way I would factor a perfect trinomial square. All right. When you have a perfect trinomial square, all you have to do is create a binomial raised to the second power, and you're going to have 2 terms in your binomial. You take the square root of the first term. The square root of x squared is x. You take the square root of the last term, which is 1 in this case. And what term goes in between? Whatever sign the middle term has. This middle term, 2x, is positive. So you put a plus sign in between. All right? Now, I know I just gave you a lot of details, but that's why these videos are cool, because you can pause, rewind, go back, copy your notes, as much as you need to. All right. Now, I just factored this perfect trinomial square into the quantity x plus 1 squared equals 9. Where'd the 9 come from? 8 plus 1. Now, we're going to use the square root property. We're almost done. Not quite, but almost though. We're going to use the square root property to first get rid of this exponent. So I'm going to do this. Check this out. I'm going to take the square root of x plus 1 squared equals the square root of 9. Now, why did I do that? I did that because I got to get rid of this exponent, because I'm trying to get x plus 1 by itself. So I got to get rid of the exponent. So the inverse of squaring something is taking the square root of something. And if I do it again, it's an equation. We got to stay balanced. Just like in life, we got to be balanced. You know what I'm saying? We got to be balanced. So if I take the square root on the left side, I got to take the square root on the right side. All right? So this is going to happen. It's going to be like x plus 1 equals plus or minus 3. And I should have threw the plus or minus sign up here, because that's something else I left out. Let me talk about that real fast. I neglected to show that it should be a plus or minus sign here, because whenever we use the square root property and we take the square root of both sides of an equation, we have to put our plus or minus sign. Now, what does that mean? That means that when we simplify this, when we take the square root of this, which is square root of 9 and get 3, the square root of 9 is not just positive 3. The square root of 9 is also negative 3. Because 3 is the square root of 9, because positive 3 times positive 3 equals 9. But don't negative 3 times negative 3 also equal 9? It does. So that's why we put our plus or minus sign, to show that we have plus 3 and minus 3. Now we got a couple more steps left. I want to isolate x. In order to isolate x, all I got to do is get rid of this 1. So I'm going to do minus 1 and minus 1. Those cancel out. And now I got x equals. Now I'm going to put the negative 1 first, and then plus or minus 3. Now, this is how I get my two answers, because remember, this is a quadratic. It's a quadratic, right? Fundamental theorem of algebra. My biggest exponent is a 2. I should have two answers, right? And this plus or minus sign is how I'm going to get my two answers, because I got to do negative 1 plus 3 to get one of my answers, and I got to do negative 1 minus 3 to get my other answer. So negative 1 plus 3, this is how I usually do it. I usually just throw an arrow on there and put one of my answers. So negative 1 plus 3 gives me positive 2. And then negative 1 minus 3 gives me negative 4. And those are my two answers. But I'm a heavy advocate of always checking your work, because if you check your work, if you take your solutions to your equation, throw them back into the original equation, and you check your work, and the left side equals the right side, and you get a true statement, right? That means that you don't got to wait for nobody to tell you whether your answer was right. You don't got to wait for your teacher. You don't got to wait for nobody, right? You just know that your answer was right because you checked it. So always check your work. So watch what I do. Now, you don't use 2 and negative 4 at the same time. You use them one at a time, right? What I mean is, some people make the mistake of this. They'll put 2 in this x, and they'll put negative 4 in this x. No, that's not how you check your work. You put 2 in both spaces and make sure that 2 is the actual answer. Make sure that the left side is equal to the right side once you do your calculations. And then you put negative 4 in both spaces and check to make sure that negative 4 is the solution. All right? So what's going to happen? 2 squared is 4. 2 times 2 is 4. 4 plus 4 is 8. 8 minus 8 is 0. So that's proof that 2 is a solution. That's proof, right? That's proof. We just proved it. All right, now negative 4. Negative 4 squared is 16. 2 times negative 4 is negative 8. 16 minus 8 is 8. 8 minus 8 is 0. And we just proved that negative 4 is the answer. So these are our two solutions. Write them up like this. 2 and negative 4. If we have to graph this quadratic, it will be a parabola, and these will be our x-intercepts, meaning these will be the points on the x-axis where the graph would cross. It would cross the axis at positive 2, and it will cross the axis at negative 4. And actually, you know what I should do? To be technical, I should follow the number line. I should write my negative 4 to the left and my 2 to the right, even though it don't really matter. It's not really interval notation for real, but, you know, just a small thing. All right, so yeah. So this is completing the square. These are the steps. It gets a little more complicated if our initial, if our x squared term or our quadratic term had a coefficient that wasn't 1. I'll do another video with an example like that, because that adds another step and it gets a little more funky. You know what I'm saying? But you know, it's still manageable. We can still do it. I'll show you how to do it. But these are the steps. And like I said, you got the video now. So, you know, go back, you know, pause, rewind, do whatever you got to do, you know. But as always, please like the video, subscribe to the page, share the video, and always remember, like I always say, there's all this math all around you. Peace.